if we look at your final exam, most schools will have a format like this. And what we notice is these are the topics. So it's 150 marks, 3 hours. And these are the topics for paper 1. We call this paper 1. And then here are the topics for paper 2. And what we notice is that Euclidean geometry is 40 marks out of this. Okay, so this is the section that we're going to revise for the next while. And it's broken up into levels that I will talk about. And I think it's a little bit like a house. You need to build a foundation, and then you can build the first floor, then you build the windows, and then, you know, eventually you can do the fancy stuff like the sliding doors and all that. But before you get there, you have to build your foundation. Okay, so just give me a thumbs up if the layout of the final exam looks familiar to you, or if that makes sense to you, that the layout of the final exam will be this, and circle geometry is in paper 2. Give me a thumbs up if that makes sense to you guys. You can see finance, growth, and decay. We've just finished that topic. Functions and graphs is what we're going to do next after circle geometry review. You can see that's a decent 45 marks. And you can see trig is 60 marks. So we're also going to do some revision on trig. And so, yeah.
Mr.
Okay.
Yeah. Is it possible that you can tell Taral what topics are going to be covered this term and which topics are going to be covered in the boot camp?
Okay, so I will give, what I'm doing here is we're going to do circle geometry for 2 weeks or 4 lessons. We're going to do we're going to do functions for 4 lessons or 2 weeks. And then we're going to do trig for 2 weeks or 4 lessons. And then I'll do just general algebra at the end of that. And that'll be the end. In the boot camp, they will traditionally focus on, basically, they're probably going to focus on functions as well, because functions is a section that people need lots of practice in. And then I think after that, it will also be based on demand from the students. So I don't think it's been completely set yet. We can probably adapt a little bit, but there'll definitely be functions and probably some trig, and then some general algebra, what we'll call, I think it's important that we go back and look at this first topic, like quadratic equations and all that. So most likely we will do it'll be the trig, and then the Euclidean geometry, and a little bit of that too, and then functions. Okay. Okay, let me go to a bit of revision. I want to do a bit of revision about circles, and you're going to help me. So I want to know, when you think of circle geometry, how do you store it in your memory? What do you have floating around? And I'd love some voices and some people in the class to come through now and just give me, how do you store it in your memory? What do you have in your memory under circle geometry? And you can put your hand up and just give me one fact, or you can audibly tell me 2 facts. I just want to do a little bit of going back in time. So Annie has said there are things called theorems that you have to know, right? I think so. There is terminology, like words that are special for this section. One of those words is a tangent. So I can see that in the chat there. Orukanisa said tangents. What other things do you remember about circles? If you had to just go and grab whatever's inside your brain right now. Some other special words that are being mentioned are chords, but not guitar chords. These are different chords. A diameter, a sector. Yep. What other words come to mind? An arc. Yep. I love it. Keep it coming. Radius. Okay, bow tie. Now, bow tie is like one of those informal things. So I'm going to put that in a different color. We've got circumference. What else am I missing anything? Oh, segments. Oh, goodness gracious. These are interesting words. Segments. Yep. What other words can you remember that you think maybe we're forgetting? So bow tie is describing a shape that is relevant in circle geometry. There are some other informal names. We've still got a couple of words. Ooh, Lindo Kuchle. you have nailed it. Cyclic quad. You need to know what a cyclic quad is. Okay. What else? Is there anything else that converse? Okay, so I'm going to put the word there, converse, because in fact, maybe I should put converse in a different color, because converses, there are a couple of converses, and we need to know what that means and how we use the converse theorems. Does anybody have anything else they want to say? You could put your hand up or tell me something, or maybe something you found hard in the section. So when you did this the first time, what did you find hard about it? I'd love to just put a bit of basic information down as we begin our journey, because we want you to like circles after this revision set of 4 lessons. So what did we find hard about circles last time? And maybe somebody can even put their hand up and just tell me audibly, it might be easier. Like, what did you find hard about this topic? What was hard about circle geometry? Providing or proving the theorems, So prove theorems, okay. Then the different reasons and how, okay, so different reasons and how to execute. So provide reasons and how to use them, Okay, these are great suggestions. Finding angles, finding angles where there are complicated shapes, in complicated shapes. I think that is it. It's these complicated drawings and finding different angle relationships in those drawings. When they use variables instead of angles or numbers, guys, you're giving such good information here. So using variables instead of angles. This is exactly what I see in I'm saying angles. It's fine for now. So recognizing the type of theorem to use. Oh, I'm going to put that in. So I'll say knowing what theorem to use, and I'll use the abbreviation THM to use. Okay, guys, you have hit it out the park. Now, what I want to say today is, as we begin to go over the stuff, if we look at your exam, there will only ever be one theorem to prove. Okay, so in your 40 marks, there'll be maybe one 6-mark or one 7-mark theorem that you have to prove. And normally this will use congruency. Now, I'm going to leave this till the very end, because this sort of stuff is more sort of like memorizing work. And so it's a question of whether or not you have the time and the memory to do that. Whereas this type of stuff, you can definitely make huge progress in terms of the practice work that we do. And I think that in order to, if I look at these things, provide reasons, knowing what reasons go with what theorem and how to use them is such a good point, right? And knowing how to find angles in complicated shapes is another one we can really make a lot of progress with. Once we have done that, then we can talk about using variables instead of angles. I think that that's a higher level skill. Like, you have to build your foundation first. And so that's what I'm going to do. In lessons 1 and 2, we're going to just work with basically the yellow stuff. And then also knowing what theorems to use. We're also going to initially start with that. So we're going to start with the yellow stuff, and then we're going to move to the basically the green stuff. And then as time allows, maybe we'll talk about theorem proofs. But because of the way the marks are allocated, it makes sense to work on the yellow stuff. And so that's where I'm going to go now. Okay, now, if we go to a very simple question, or not say simple, but just seeing what we remember from earlier in the year, let's go to a simple question now. Now, let me get rid of all this. I want us to just try and answer this one question here. So I want you to try and think back to when you did circle geometry and give me an answer in the chat Or if somebody feels like they know the answer and the reason, I want you to put your hand up and tell me what the angle and the reason is. Okay, let's go to Oratiwe. Oratiwe, what do you think the answer is and what reason would you use? Can you hear me, Oratiwe? Can you hear me, Oratiwe? I see your hand is up. I think you're unmuted. Hey, what do you get?
It's going to be 124 divided by 2.
Divided by 2.
Yes,
Perfect.
and the angle at center. So 2 times angle at center.
Yeah, so awesome. So the reason that's being used is the answer is correct. The answer is 62. So it's not the same angle. It's actually half. And the theorem that we do here is that the angle at center equals, sorry, I'm hitting the wrong button here. Angle at center equals twice angle at circumference. And so angle is this abbreviation. This is a 2. Sorry, my writing's a bit dodgy. And so this will be 62. And sometimes we call this theorem the arrowhead. And the reason it's called the arrowhead is it looks a bit like an arrowhead, although there are other shapes. And the way I teach it to my students is I say, look, if you have an arc or a chord between 2 points on a circumference of a circle, if you form an angle at the center, there's your angle. And then if you use the same points and you make an angle at the circumference, then that angle has to be half of the angle over here, which is 62. Okay, cool. So that's just remembering like a basic fact. Now let's try and do another one. Find the value of X and find the value of Y here. And put it in the chat, or if you feel like you can answer it audibly, then you can put your hand up and I'd love to hear from you. What do we think X is and what do we think Y is? So just to make sure that you know, this is the 244 over here, huh? So be careful, exactly. So what I'm going to say to you guys is AOC is actually equal to 360 minus 244. And the reason is angles in a revolution. Now, if I take away 200, I get 160 minus 40, I get 120. So this is 116 over here. Now that may affect your answer, huh? What do we think the answer for X is now? And what do we think the answer for Y is now? Now, it's interesting, it's a little bit more tricky, this drawing. So I was thinking of getting the X first, although you don't have to. So think about the shape that we did before, where we went, there's the angle at the center, right? And there is the angle at the circumference. So X is going to be 58 degrees, and it's going to be the same reason as before. Angle at center equals twice angle at circumference. Now, with the Y, the reason the Y is so tricky, and there's 2 ways you can do this, is another way of seeing an angle at the center is to think of the angle Y being the angle at the circumference, but then the angle that goes with that Y over here is going to be this big green one up here. And so you could say that Y is going to be 122 by the same reason the angle at center equals twice angle at circumference. But that will catch a lot of people. I think a lot of people struggle to see that. Now, there is another way to do this. Now, you mentioned the word to me earlier on called cyclic quad, and I just want to highlight something. A cyclic quad is a quadrilateral where all four sides are on the circumference of a circle. Now, if you know that x is in fact 58, right? So you know x is 58. What's another way you could find y if you know about theorems about cyclic quads? Maybe somebody could put their hand. Oh, I see Mali and Zanele have already put. Who would like to explain how they find y using properties of a cyclic quad? Just pop your hand up if you feel like you can explain how you would do that. Okay, let's unmute Orokanisa.
Hi, sir.
Hey, tell me, how would you find y using the properties of cyclic quads?
We'll find y by saying that opposite sides of a cyclic quad is equals to, when you add them up, they
Yes.
must give you 180.
Okay, so can I go 180 minus 58 because that's what is on the other side, yeah?
Yes, sir.
And what would your reason be?
Opposite, will be
Yeah.
opposite angles of a cyclic quad equals to 180.
Yeah, no, you can just say opposite angle cyclic quad. That's enough. So opposite angles cyclic quad. That's it. Opposite angle cyclic quad. And then you would get, what are you going to get? 122. Now, I think most people would find getting the 122 like that a bit easier. But just to show you how, if you have a circle, and let's say you have the center of the circle and you have these 2 points on the circumference, you can make an angle over here at the circumference, and you can also make an angle at the center. But we're so used to the angle being here, we forget that you actually can have an angle on the outside here. And then that would be go with this one over here. And you can kind of see this one is huge, and then this one is also quite big. But I think for most students, seeing that a cyclic quad's opposite angles adds to 180 is much better. Give me a thumbs up if you are feeling, if you could follow that argument. Give me a thumbs down if you are feeling a bit lost. I am assuming that you have a bit of basic knowledge, but it might be worth, it depends on what the room is like as to how much. So we're going to stay with these simple questions today, or simple-ish, and learning the knowledge that we're building the foundation today in our revision. Okay, so we'll just take it one step at a time. Okay, let's do this one. Now, what I want to point out with this question is that the shapes that are relevant here, there's no angle at the center, but there is something called a cyclic quad. And so the facts or ideas that you need to activate in your brain will have to do with cyclic quads. So can you find for me X, Y, and Z and put that in the chat? So this is a cyclic quad. There's no debate because you can see the vertices A, B, C, and D are on the circumference. And then if you feel like you can give me the answers, then pop your hand up and you can tell me and I'll write them in. And remember, it helps. Also, the conversation helps other students in the class too. So don't be afraid to. So we know we need, okay, Tsegavatso, let's go to you. Which one do you feel like? Good afternoon, sir. Hey, which one do you feel like you can do first?
X. I think I can do X first.
Okay, go for it. What is X?
I think X is 100 degrees.
Brilliant. You smashed it. Can you give me the reason?
Exterior angles of a cyclic quad are equals to opposite interior angles.
Yeah, no, you can just say, here's the wonderful thing, exterior angle cyclic quad. So you can just say exterior angle cyclic quad. This is the exterior angle. And so you know that will be equal to that one over there. And so you're
Yes,
right,
sir.
it's 100. Perfect. Could you do Z?
Yes, sir. Z is 80 degrees.
Perfect. Reason?
Opposite angles of a cyclic quad.
Aha. Well, what you could do, yeah, opposite angles cyclic quad, or you could also use angles on a straight line. That would also work. Okay, and then what is the last one? It's Y. Can you do Y for me?
Y is, I think, 90 degrees.
Yeah. And it's going to be the same reason, opposite angle
Of
in a
the
cyclic quad, because
Yes,
they
sir.
have to add up to 180.
Yes, sir. Thank you.
Thank you, Tegamatsu. That was brilliant. I can see you know your cyclic quads. All right. Bianca has a question. Bianca, I don't know if you have a question. Go ahead.
So for Z, how did we get the 80?
For Z, how did I get the 80? Okay. The one way of doing it is to say that this is a straight line. And so there's already 100. And what's 100 plus what gives you 180? It's going to have to be 80. Or you can say that you just worked out this was 100. And the opposite angles in a cyclic quad need to add up to 180. So we went 100 plus this must equal 180. So what does that X need to be? Well, it's not an X, it's a Z, but it can only be 80. Does that help?
Yes, thank you, sir.
Cool. Okay, let's try another one. Let's do this one. So we are given a circle with center O and a chord. There's that fancy word that you guys mentioned earlier, a chord AB. And a chord is just a line that goes from one point on the circumference to another, but is straight line. And the chord is 16 centimeters in length. D is the midpoint of AB. AO is 10 centimeters. So AO is 10 centimeters. Determine the length of OD. So where is OD? OD is here. Find me the length of OD, and I want you to use the correct reasons as we go. What do you think? This is going to be. So you have to ask yourself, what theorems are relevant? I don't think cyclic quads are relevant. But maybe there's another theorem that maybe somebody can help us. Anybody feel like they might know a hint for the rest of the class? Ooh, Orokanisa said Pythagoras. I think you're onto something. But before we can invoke Pythagoras, what does Pythagoras need to be in place for Pythagoras to work? So I agree, Orokanisa, I think that's a great tip. Pythagoras could be involved. But what do I need to prove to make sure I can use Pythagoras? Two sides. Okay, Morgan, you're absolutely right. So I need two sides. Two sides in what? You can work out the length of A and D, perfect, but you need two sides in a right-angled triangle, don't you? So you need a right-angled triangle. Now, what does a right triangle have? It has a 90 degrees. So the theorem that you needed to start with here is to say that OD is perpendicular to AB. So basically, OD is, and what is the reason? It's a line from center, so line from the center to midpoint of the chord. So this is not as well known as the other ones, but if you have a line from the center to the midpoint of a chord, it will be at 90 degrees. Now, once you know that that is a 90-degree triangle, it also tells you this is the midpoint. So this is 8. And this is where our friend Pythagoras can come in. We can say 10 squared equals 8 squared plus OD squared. And the reason is Pythagoras. Now, what is OD going to end up being? So we should have 6 centimeters. So we know that this thing over here is 6 centimeters. Okay, Zwandile, let's go to you. What is your question? I think we maybe, there we go. Can you hear me, Zwandile?
Yes, sir. Can you hear me?
Perfectly. What is your question?
How did you get the 8?
How did I get the 8? All right. In the question, it says
Yes,
the
sir.
chord is 16 centimeters. So the chord over here is 16. But it says D is the midpoint. And midpoint means in the middle or halfway. So what's halfway? Or what's half of 16? It's 8. And so what we know is this bit here is 8. And
Okay.
this one over here is 8. Does that make sense? Is that okay, Mzondile? All right. I think
Yes, sir.
that's
Thank you, sir.
perfect.
Yes, sir.
Okay, everyone, I think it's time for our break. So what I want you to do is I want you to stand up with me. And I want us to just give our bodies and minds a rest. We've done some good, you've done some good revision so far. And I think what we need is our brain to unlock all the other circle geometry facts we've learned in class. And so in order to help with that, we need to move. So turn on your cameras. Let me see your lovely faces. I do enjoy seeing where all my students are. And I want you to stand up with me. And I want you to just stretch up and have a nice deep breath. And hold it and breathe out. And another nice deep breath. And then one more nice deep breath. And yeah. Then let us just do a little bit of rotating with our arms. So we start with a nice loose waist. And then as we start to turn, our body is relaxing. And I start to turn a bit further. Before I know it, I'm almost turning the whole way around. And that can only happen if I'm relaxed. Okay, then let's roll our shoulders a little bit because they get quite tight when we're scrunching forward. And roll them forward. Let's do some small circles with our arms. Into big circles. And then we're changing direction, big circles into small circles. Okay, then let's do some tricep. Switch to the other arm. Okay, and then just shake it out. So shake out your arms, shake out your legs. And hopefully your body's feeling a little bit looser. Let's do some heart rate stuff to get the blood pumping. We're going to do jumping jacks, which is always a bit of fun. A jumping jack is just like this. And I get quite tired, so I hope you do too. And let's do 20. And 3, 2, 1, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, halfway, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, okay. That is that for the exercise for now. And then just to get our times table brain working, here is 2 Maths 24 questions. And so the goal with Maths 24 is just to try and make 24 with these 4 numbers. That's a 9 because the line is at the bottom. That's a 6. And so those who are new or anything, we just basically have to use each number once to make 24 using the normal operations and brackets. Okay, Sanelisiwe has said 8 plus 7 is 16 plus 9 times 1, which I think gets me to 15. Oh, that is 24. Yeah, 8 plus 7 is 15, plus 9 is the 5 and the 4 is 24. And 8 plus 9, oh, or you can go, I see other students are saying 8 plus 9 plus 7 times 1, which would also give us 24. And Morgan also got 9 plus 8 plus 7 minus 1. Oh my goodness, 9 plus 8 minus 1. So that would be 20, that would be 6. I think, Morgan, I'm not sure if that works exactly. 17, 24. No, or you could say, yeah, you would need to use that one, like divide by 1 or something like that. Okay, does anybody get the blue one? Oh, certainly see where you're on form today. Sheepers. Oh, okay, no problem, Morgan. So let's have a look. 3 times 6 plus 5 plus 1. And Tegawatso has said the same thing as Sanelisiwe, 6 times 3 plus 5 plus 1. So that's 24. Okay, well done, everyone. And Sadiq, you're also the same. So that is great. All right, I think we've done enough brain break. It's time to get back to the circle geometry, but I hope you guys enjoyed that. And yeah, you feel like your brains had a break from the circles and we can now go back and have a look at them. Okay, things are getting a little bit more exciting here. We have PS is a diameter. So PS is a diameter, and there's some new facts or new ideas that come into play when we have that. We also, do we have a cyclic quad? You know what? It's a sneaky cyclic quad, but it feels to me like that's also a cyclic quad. Okay, try and find me what X, Y, and Z is. Try and find me what X, Y, and Z is. To think about what relationships are involved here. And if there's a student who feels like they know what X is, I would love to hear from you. I'd love to hear how you got it, what you think it is, and just pop your hand up and we can have a conversation and you can help everyone else in the class. It's not obvious what X is, but I think someone might know. Oh, okay. Sorry, I wasn't looking at the chat there. So lots of students are saying that X is 60 and some students are saying X is 120. Who would like to defend their point of view? Is it 60? Is it 120? So I think that this 120 out here is the exterior angle of the cyclic quad, which means the interior opposite must be the same. Yes, Mbali and Zanella, I see that. Fantastic. So X is 120, and we just say exterior angle, get rid of this, cyclic quad. So we know that's 120. Now, what about, okay, so that's fine. Give me a thumbs up if you understand why X is 120. Just want to get a feel for the group. Did we all understand why that the blue cyclic quad is there? And then the 120 is the angle. So like we call this the interior, and that's the interior opposite. Okay, now we need to find Y next. Who wants to tell me how to find Y? Who wants to tell me how to find Y? Yeah, Orokanisa, can we unmute Kia Orokanisa? I think Orokanisa has an idea on why.
I just want to try, sir. I think Y
Yeah.
is going to be 90 degrees because it's an angle subtended by the diameter.
Okay, perfect. Yes, 90 degrees. So sometimes we say angle in the semicircle or angle subtended by a diameter. Both are fine. I'm just going to say angle in semicircle. And you're quite right. The diameter subtends an angle of 90 because it's almost like a version of the angle at the center is twice the angle at the circumference. Like if this is 180, then this one over here has to be 90. We call that angle in a semicircle. Perfect. What about Z? Could you help me with Z? Okay, maybe you've, see, okay, not on the line, that's fine. Last answer for Z. I just think if you know this is 90 over here, now I think, what else do we have here? We got that over there. Well, I think this has to be 60, right? Because of angles on a straight line. So I'm just going to say that SPQ is equal to 60. And I'm going to say angles on a straight line. And then once I know that's 60, I'm going to use the fact that in a triangle, the angles have to add up to 180. So if I go 180 minus 60 minus 90, and I put angles or sum of angles in a triangle, let me rather put that. So sum of angles in triangle, then the answer for Z must be 30. Okay. Now we're definitely noticing that the drawings are getting more complex, which is good. Now I want to find one. I think we've done that one already. So we're going to skip that one. Here we go. Okay. So I want to know what is different about this question compared to the previous ones we've done. Oh, Bianca, you want to take a screenshot? Let me go back quickly. And then you can take a screenshot. That's fine. And then I want everyone to identify what is different about this next question. Okay, so what is different about this question? What shapes or what knowledge is different in this question? Yes, there's a tangent involved. Look at the this thing over here that touches the circle in just one place is called a tangent. And this point over here is called the point of tangency. Now, the theorems that come with tangents are the tan radius theorem, but there's no radius because there's no center point. And then there's something called the tan chord theorem. And sometimes we call that the windsurfer theorem because the shape looks a bit like a windsurfer. Okay, now I'll give you that hint. We're going to use the tan chord theorem. I want you to find me X, Y, and Z. Okay, Ayanda's got the answer coming in there. That's fantastic. So X equals what? So what I'm going to do is I'm going to trace the shape out for you, just so you kind of know what I'm dealing with. So the angle between the tangent and the chord is 45 degrees. And then that has a relationship with the angle in the alternate segment. So these angles are going to be in relationship. So this 45 is the angle between the tangent and the chord, and this is the angle over here in the alternate segment. These are equal. And so we call this is the tan chord theorem. And so we just say tan chord, or we can just say tan chord theorem or tan chord, it's fine. It's tan chord. And so X is 45. Now, what is Z going to be, or Y going to be? Well, I see a lot of students are already seeing the same sort of relationship, except the other way around. And so they can see that if we look at the angle between the tangent and the chord over here, this Y, this is going to be the same as that one over there. And so we can say Y is equal to 60 by the tan chord theorem. So that's going to be 60. And then the last one is Z. What's Z going to be? Okay, Masek was asked, so my teacher said that if we use the tan chord, we should state which one. It's not, that's not what I mean. Let me have a look at the formal reasons. So let me quickly have a look. Resources question. Extra resources. Where did I put it? Summary reasons. Here we go. Okay. If we look at the tan chord theorem, that's not what I have. All that you need to show, sorry guys, so in terms of the official reasons, so the one thing maybe you could debate is whether or not we should add a THM for the tan chord theorem, like we'd write. So if you really want to be on the safe side, writing that, but you don't officially have to write, it's probably not a bad idea in terms of understanding, but it's not an absolute requirement. Okay, sorry if I jumped around a bit quickly for people there, but yeah. Okay, what is Z going to be? So Z is going to be 180 minus the 60 and minus the 45, which is 75 degrees. And our reason is going to be sum of angles in triangle. Okay, let's do another one with tangents, hopefully. Okay, we did that. We'll come back to that. Yeah, let's do this one. Find me X, Y, and Z. In this question, OT is a radius. So OT, and you can kind of see this, it's a line from the center to that. AB is a tangent. So here is my tangent. And you need to find me X, Y, and Z. Go for it. Okay, so I think I'll give you this hint. OT is perpendicular to AB. Now, why is, well, basically this, what's that theorem called? Or another way of saying this is angle OTB is 90. So what is the reason I have to use for that one? How do I know this one is 90? You can pop your hand up or you can put it in the chat. What is, how do I know that this one over here is 90? Yeah, this is the tan radius theorem. So the angle between the tangent and the radius will always be 90. Now, if you know this is 90, this makes it easier to get x. X is just going to be 180 minus 90 minus 36, sum of angles in triangle, which should give us 54. Now, what about y and z? Goodness gracious. What are they going to be? So, Orokanisa, I agree. There's actually two ways you could get the answer for y, and you've chosen one of them, yes. So the one way of getting y is to say y is 90 degrees, and the reason is the tan chord theorem. Or some people may have spotted this as a diameter, and so y has to be 90 degrees because of angles in a semicircle. And so both those reasons would be correct, but y is 90. Then what is z going to be? Well, if this is 90 and that is 30, that's 120, then together that has to be 60. And that will be sum of angles in a triangle. Okay, is it time for one more, everyone? Have you got one more question in you for today? Can we squeeze it in? How are you feeling? I think we can do it. You've done well. This has been a good reintroductory. Okay, here's the last one for today. Now, we're starting to get into the more exciting shapes. Some people might say they see a butterfly here. Some people might say they see not a butterfly, but they see something else. Who knows? What I want you to find is Z and Y. So see if you can find Z and Y. What they do say is that O is the center point. So that's good. O is the center point. And yeah, it feels to me like maybe the arc or the chord AB could be helpful to think about. But I'll leave it to you guys. Ah, bow tie shape. Okay, yes. There is a bow tie shape going on. I agree. I agree. Because we haven't spoken too much about the bow tie today, but a bow tie is formed when you have a cyclic quad kind of, and for me, A, C, B, and D do form a cyclic quad, but the lines are crossing, or the diagonals are crossing. So that gives us the bow tie. What is, you could do Y first. What is Y going to be? It's going to be 68. And what is the reason? What's it called? What's the official name for the bow tie theorem? It says if we've got a cyclic quad with basically an arc, angles in the same segment. Yep. Angles in same segment. And the segment they're talking about is if you imagined like drawing a straight line, sorry, that's a straight line, then this is the one angle over here in the same segment, and this is the other one over here. So these ones are in relationship. Okay, what about the Z? What's that going to be? What's the Z going to be? What I'm feeling reminded of something right back in the beginning of this lesson, where we talked about the angle at the center and then the angle at the circumference. So what does Z have to be? Well, Z is going to be double 68, which is going to be 136. And the reason is going to be angle at center, excuse my dodgy writing, angle at center equals twice angle at circumference. Okay. So everyone, what was today about? Today was about building a foundation and starting to get those simple, those circle geometry pictures and facts back into your head. On Wednesday, we're going to start to keep going like this, but we're going to start to look at, I'll even show you a little bit, a question like that, or even, carry on with stuff, and then maybe get to slightly more complicated, and we'll just start turning up the heat session by session in terms of your awareness of how to find these shapes. Okay,